Okay, hello everyone, good afternoon and welcome to today's webinar. I'm Lindsay Teal and I'll be hosting the webinar today, which should last around 40 to 45 minutes. The webinar will be delivered today from Brendan Reid, and I'll hand you over to Brendan in just a second. Brendan is one of our energy experts here at Resource Efficient Scotland and has worked on many lighting efficiency projects and initiatives across a range of Scottish organisations. So he'll share his knowledge with us today and insight, which will be great. If you want to ask any questions throughout the session, you'll see on screen now that there's the questions box, which you'll see on your own screen, and if you just type any questions into the box there at any point throughout the webinar, they'll come to me, and at the certain points we'll stop and we'll take as many questions as we can. Also on there's the hashtag #ResWebinar. So if you use Twitter and you'd like to post any questions or any comments throughout the webinar, then if you could just do so by either directly to us at Resource Scot and using the hashtag #ResWebinar. So that's it. So I'll hand you over to Brendan now and we can get started.
Great, thank you very much, Lindsay. The aim of this webinar is to help you understand your energy bill and look at the options you have to reduce your energy bill by taking advantage of the latest lighting automation and lamp technologies. So let's dive straight into it. The first section is really important, is to understand a little bit about your current energy use, your data and the costs you have at the moment. So let's look at how you can understand and calculate that. I think we're going to do a quick poll on this, so I'll just hand over to Lindsay quickly.
Yep, I'll just share that with you on screen now. The poll is, do you fully understand the amount of energy your lighting is costing your organisation? So if you could just take a few moments to complete that, it'd be really interesting to see before we go on to explain how you do that, just where everybody's at. So those results are coming in now, which is quite interesting. It's quite evenly split between yes and no. Still some answers coming in. I'll just close that and share the results with you. So they should be coming on screen now. So the final result there is 47% yes, 37% no and 16% are not sure. So it's quite interesting, quite positive that 47% actually do know and understand what the lighting's costing them. And certainly we hope that there'll be some content in the webinar today for you, and for the others I think you'll really get benefit from today's session. So I'll just hand you back to the Brendan and the slides. Okay, the slide should be coming back on screen now.
Great, thanks Lindsay. So let's just move on to how you can understand your energy use. So electricity consumption is measured in kilowatt hours, a kWh, and a kilowatt hour is an amount of electricity. In fact, it's 1 unit on your electricity bill. And a kilowatt hour is the amount of energy used when a 1000 watt appliance is running for 1 hour. And the cost of a kilowatt hour varies according to your particular organisation's electricity tariff. If we look at the bottom left hand side of the slide there, we can see that a 1 bar electric fire uses 1 kilowatt. So again, running for 1 hour, it will use 1 kilowatt hour. And if we assume a typical price of 13 pence per kilowatt hour, you know immediately that bar fire is using 13 pence per hour to run. In a similar way, in the lower right side of the slide, we've got another example with lighting. So in this case, if you've got 10 lamps each using 100 watts, then together that uses 1 kilowatt, and again the cost of that is 13 pence per kilowatt hour, 13 pence per hour to run that lighting. So it really is quite simple to understand how much appliances use and what it's costing you. If we look at the whole organisation now, there's 2 approaches to estimating your energy use for lighting. So one would be what you would call the top-down approach, where we look at the whole electricity bill and we try to break that down into a proportion which might be used by lighting. And so we do that by first estimating the annual consumption, and you might do that by extrapolating up from 1 or more bills. and you might have to net off any standing charges or other charges on your bill. And then once you've got that net amount, then you can try and estimate the proportion of energy used for lighting. We'll do an example of that in a few minutes. Another approach you might call the bottom-up approach, and this is where you do a little bit of a lighting audit for your organisation. So you go around and identify all the lamp types, all the fittings that you have, both interior and exterior. You count the numbers of each lamp type, and then by simply estimating the run hours per day and the days per year that they're operating, we can calculate the total energy that's used for your lighting. So let's look at a couple of examples of those approaches. First, the top-down approach. We said we'd start with the total electricity use per annum. So that's the formula shown in the top left-hand side of the slide there. And if we look to the example on the right-hand side, what's happened here is somebody's got a bill of about 36,000 kilowatt hours in a month. They've decided that the electricity is reasonably flat through the year. It's used pretty much the same month on month. So they've multiplied by 12 to get a total kilowatt hours per annum of around 440,000 kilowatt hours. Then you need to subtract any energy that's related to process use. So for factories and so on, you try and subtract any process use electricity. You'd also subtract any heating use. So for example, for storage heaters or electric panel heaters. Once you've done that, you're left with the general electricity that's used for your offices or your factory. And it's a general rule that about half of the remaining electricity will be used for lighting. So in the example on the right hand side, you can see that we have a remainder of about 100,000 kilowatt hours per annum is being used for general electric use, for general lighting use, sorry, and that equates to about £13,000. So you can see that you can reasonably quickly go from an overall electricity consumption down to a number that's related to your lighting for each year. So that's the top-down approach. The bottom-up approach, which I already mentioned, you need to go around and do this audit, plug in each type of light you have, a wattage rating for each lamp, and then the run hours that each lamp operates for. And to make that easy, we've got a free lighting cost calculator, which you can see at the link that's at the bottom there, and that makes it easy to do that calculation and do the bottom-up approach. So I think we've got another poll now. I'll just hand back to Lindsay to run that.
So we're just about to move on to lighting control measures, and before we do, we just wanted to ask, where do you use lighting controls in your organisation? So that should be coming on screen now, and there's a couple of options there, which is we don't, in the toilets, in the corridors, in the meeting rooms, or if you've got another place that you use those lights. So if you'd like to complete that, then that'll give us some insight into where you're using those. So we don't have any in our organisations kind of winning outright at the moment, and also in the meeting rooms is quite a popular choice, and in the toilets. I think most people have completed that now, so I'll just close that and share the results with you. So they should be on screen now. So yeah, as you can see, we don't use any as the most popular choice, so I think you'll gain a lot from the next section, which Brendan's going to talk about. So I'll just hand you back over to the slides now. Hopefully they're coming on screen. Bear with us. That's it. Sorry about that.
Great, so let's go on to talk about lighting control strategies. And the reason we're putting this first in the presentation is because it's one of the simplest and most cost-effective ways that you can choose to look at your current lighting. So one of the simplest ways of making the most of your lighting is to make the most of natural light. So some things you can do here are ensure that windows or skylights are clean. You can make sure that Furniture or other obstructions are moved out of the way to allow as much natural light into the rooms as possible. You can make sure that any blinds that you have fully retract to the side or fully retract to the top to avoid obstructing light on days when you want it to come into the rooms. And it's quite important as well to consider how you locate desks. There's always an issue with glare onto the screens on IT equipment that we all use so much these days. But careful placement of desks can minimise that, and it's best to locate desks side on to windows, as is shown in this example here. The other point about this example is we're making most of natural light for the working area down the sides of the room, whereas the corridor in the centre needs less light and it's further away from the windows. So some good tips there. Other types of lighting controls that we can use in a commercial environment are various types of presence detection. And the reason these are needed is that very often there isn't one person with clear control of a particular area. And in that scenario, no one person tends to take responsibility for control of lighting and switching off to prevent wastage. And it's a very fruitful area for energy savings. You can often save more energy and have a lower payback by looking at controls of this type and even changing lamps for newer and more efficient models. So there's a number of types of lighting control that are used quite commonly. So there's presence detection, where you'll also hear people talking about absence detection. There's timers, which may need to be adjusted a couple of times a year at least as the clocks change. And there's daylight sensors or photocells, which are detecting ambient lighting conditions and responding to that and controlling lighting on the basis of that. Let's look at some types of presence detection. A very common one that you'll hear is passive infrared or PIR units. These emit a beam of infrared light which is not visible to the human eye, but they're, as might be obvious from the type of output from them, they're good at long thin spaces, so very good for corridors or rooms which are elongated. You also get PIRs with manual controls integrated into them, and they're quite good where you have people who wish to control the lighting manually, but then if they don't control it manually, the PIR will detect when they've left the room and will switch off the lights after a certain period. Microwave detectors are a different type, and they are very good at wider spaces and more complicated spaces which have a lot of equipment in them. So they don't depend on a single beam pointing out as the passive infrared detector does, and they can be used for larger areas. So lighting controls are great for intermittently occupied areas, and that's where you get the most benefit from them. It's very easy to walk around areas within your own businesses and see locations where lighting's left on when it shouldn't be. And very often you'll find these are WCs, storerooms, corridors and meeting rooms. And these are all used often during the day, but only for short periods. And that's where lighting controls can give you a big benefit. You do have to be careful when fitting controls that you get the time periods right and that you don't irritate your colleagues and customers by having the controls set to turn off too quickly. A classic example is setting the controls too short in the bathrooms, and then people are waving their arms in the air in the dark and not very happy about it. So lighting controls are quite often, daylight sensors or photocells are quite often used in exterior locations to control exterior lighting or street lighting. but they could be used a lot more internally, so do have a look at whether they'll be appropriate for your sites. They often require appropriate zoning of lights, so for example, in many offices there's a row of lights next to the windows which is almost always on, and in fact if there was a photocell controlling them, they could be switched off during the day for a large proportion of the year. So photocells can be a very good option in that situation. You also get combined units with photocells and presence detection in one unit. So here's an example of a zoned office where you could make use of photocells. And it's just what I was talking about previously, in that we have good natural daylight coming in from either side of the office through windows, and we have a darker and less lit area in the centre of the office. The distance which light can penetrate into, good quality light can penetrate into the office it's a function of the design of the building. It's to do with the size of the windows and so on. So you can't change that. So nearly always in the centre of offices there will be a requirement for fixed artificial lighting. But down the sides, if you could fit photocells in two different zones there, then you'd get a big benefit. And whether you could do that is sometimes down to how easy it is to change the wiring and the way that the wiring is laid out. So in this example, if the wiring was laid out across the way, that would take more work. If you had lighting with wiring already up and down, it might be quite simple for an electrician to fit photocells into an existing scheme. So let's move on now to look at a worked example of lighting controls. We're going to consider a WC in a single shift factory, and currently the first person switches on the lights in the morning and they're switched off at the end of the day by the security guard. In this example we're going to consider operating for 10 hours a day, 5 days per week and 50 weeks per year. And let's consider the example of 20 employees visiting the WC, say 2.5 times per day, typical figures. So in the WC we start out with 8 halogen lamps, that's a kind of halogen spot type, each of a wattage of 50 watts. So we have a total wattage of 400 watts or 0.4 kilowatts. And just by multiplying up 10 hours per day by 5 days per week by 50 weeks per year, we get 2,500 operating hours per annum. And then it's pretty easy to work out kilowatts times hours gives us 1,000 kilowatt hours per year. So at 13p, that's £130 you're spending just on one WC lighting. Quite a lot. So how could we change that if we put some controls in? Well, we've got the same number of lamps. I'm just stepping down the right hand side of the table now. The same wattage. But now we're going to assume that we have 50 visits, that's 20 employees visiting 2.5 times a day, for 5 minutes for each visit, and then for 5 days a week and 50 weeks per year. And that brings the operating hours down to 1,041 hours per year, so less than half what we had originally. And you can see there the annual cost drops to £54 and a saving of £76 per annum. So a really good saving for a relatively small change and relatively cost-effective change to make. So I think that concludes our little section on the lighting controls.
Yeah, and we've got some questions come in, so we'll take them just now before we move on to lamp replacement. You've touched on this a little bit already, Brendan, but someone's asking that they've installed PIRs in the bathroom, but staff were often left in the dark if they were in the cubicle too long. So just, is there an alternative or a better way to make this work?
So one option would be to look at the type of detector. PIR in this case you said, so you could possibly look at a microwave detector. and that would have a wider view of a wider area in the bathroom. That might sort the problem. It might be as simple as just adjusting it to have a longer time set so that people are in there slightly longer with the lights on, and yeah, it should be possible to make that work.
Okay, great. Someone's asked, I would like to fit lighting controls but need to keep my colleagues in health and safety happy that the lights aren't going to be switched off and it won't lead to accidents.
Yeah, this can be a tricky one, and there's a couple of different ways of approaching it. It's very common in places like factories with, for example, forklifts moving about and through doorways and so on. There's big concerns about using controls in that scenario. One option is to have very careful placement of your detectors so that anybody entering the space, even before they've got into the space, has already switched the lights on, and sometimes in some layouts that works and sometimes it doesn't. Another option is to control maybe only half your lights on automatic controls. So you retain some lights which are switched on permanently, which provide a background level of light, and then you control the rest of the lights via the automatic aspect. And that provides both cover for the health and safety aspect and gives you energy savings as well.
Okay, great. So that you covering off the zoning would be really useful there. Another question is, we aren't able to set our office desk like the example you showed on screen to make the most of natural light, but we've got complaints. Some people are feeling that they're getting glare and some people are feeling that their desk is too dark. Is there any way to make everyone happy?
Well, making everyone happy is a bit of a tricky one. We all know it's quite tricky in some offices to keep everybody satisfied. There are some things you can do. One option would be just to consider the decor in the office. Having light coloured walls is going to be a very big benefit to making the place feel light and airy, so it's worth considering the decor. Another option might be to consider the type of blinds that you have. So on bright days where there's glare is a problem, it tends to be lights go on and blinds come down. And that's not a very energy efficient option. But you do get lights which, you do get blinds which can be used set at an angle which bounce the outside light up onto the ceiling and then deep into the office and provide good background lighting. So that might be an option.
Okay. One other quick question is, how much do these technologies tend to cost?
PIRs tend to be sort of £30–40. You maybe allow a bit more for that by the time the electrician's fitted them. Microwave ones tend to be a little bit more, not much. And then you get the combined units, which are a PIR and a photocell in the same unit, and they might be £50, £60, £70.
Okay, and so people should just make sure they get enough quotes to find the best possible price for an electrician.
You can see prices in B&Q for these units. They're available there. You can obviously ask your electrician for a price for a particular unit. Yep.
Okay, great. Well, we're just going to move on and do another quick poll, and then don't worry, we'll ask some more questions at the end. So the poll we'd like to ask now is, do you know what type of lights that you have in your organisation? So that should be coming on screen now, so if you'd like to just complete that. Excellent. So 63% at the moment are saying yes, that they know all the lights that they have in the organisation, but there's still about 35% or so, it's kind of changing all the time, that don't know what their lights are. So this next section will definitely be of benefit to you. So I'll just close that poll and share the results with you before we move on to talk about lamp replacement. So you should be able to see those final results there. So 67% yes and 33% know some of their lighting but not all. So I'll just close that and I'll hand you back over to Brendan.
Okay, thanks Lindsay. So let's move on. We've looked at controls. Let's move on to look at lamp types and lamp replacement options that you might have. And there's a lot happening in this space at the moment. There's a lot of new technologies coming forward. You'll be aware of LED, which we're going to talk about in some detail. But there's really quite a lot of options for any particular lighting that you start with. So what are the things you should think about before you start replacing lights? Well, it's well worth doing a little bit of a lighting survey just to check that lighting levels are sufficient for your current space, the current use. And you can get, in the picture at the bottom right there shows a little lux meter, and you can walk around. It's best to do this, or actually in winter evenings a great time when there's no natural light coming in, but take your readings when you're depending just on artificial light and see what lux levels are there at the moment. I've put some typical lux levels for different spaces in the column on the right hand side of the table there. So you can see 5 to 15 lux might be external street lighting type. 150 lux for corridors is quite comfortable. Warehouses are often at that kind of level. Anytime there's close work or office type work, it tends to be higher, 300 to 500 lux. Inspection areas, for example in factories where there's really close inspection needed, they need to be up at 500 lux plus. And just as a bit of a comparison, outside in an overcast day might be 5,000 lux, and outside in full sun might be 30,000 lux. So you can see what that tells you actually is how responsive the human eye is, because we can come from outside 30,000 lux into a corridor at 150 lux, and our eye is doing a huge amount of adjustment to the actual light levels that are there. Going back to what you should be looking for when you're considering lamp replacement, you need to look out for any areas that are overlit, so lux levels that are in excess of these kind of indications that I've given you today. Lower levels of lights, for example in corridors, can be quite restful and satisfactory, and check with your health and safety officer